Hello, today we're going to be taking notes on isotopes. I need you to copy down everything that is in red. As always, if you need to, please pause so that you can get the writing down, or you can open up the slideshow after viewing this video. So another word for isotope is basically a version. Isotopes are different versions of an element. Atoms of the same element with different numbers of neutrons are called isotopes, or they're different versions of that same element. Technically, because an isotope is just a version, every atom is an isotope. Some elements have lots of isotopes, others don't have very many. Depending on the number of neutrons, an isotope can be stable or it can be unstable. We'll talk about that more in our radioactivity unit. Besides having different masses and maybe being stable or unstable, different isotopes of the same element are nearly identical and have all the same properties. Here are the 4 known isotopes of carbon. Carbon 11 has 6 protons and 5 neutrons. Carbon 12, which has 6 protons and 6 neutrons. Carbon 13, which has 6 protons and 7 neutrons. Carbon 14, that has 6 protons and 8 neutrons. When we talk about different versions of an isotope, we identify them by their mass numbers. Remember, mass number is protons plus neutrons. So this version right here is called carbon 11. The most common version, carbon 12. We also have carbon 13 and carbon 14. Here are the 3 known isotopes of hydrogen. Hydrogen 1, hydrogen 2, and hydrogen 3. Notice you can write the whole name out or just use the symbol like I've done here. Hydrogen 1 is a version of hydrogen that has a mass of 1. We already know that hydrogen's atomic number is 1, which means it has 1 proton, and that means that it has no neutrons in its nucleus. Hydrogen 2 has 1 proton, and it also has a neutron. Hydrogen 3 has 1 proton and 2 neutrons to make that total of 3. Every version of hydrogen is going to be one of these 3 isotopes. Isotope notation is all about how we write it down, where we indicate the mass number of our isotope. You can indicate it in one of 2 ways. You can write the name, dash, and then the mass number, the symbol, dash, and the mass number, or you can write it as a superscript before the symbol. Let me show you what that would look like. So if we have iron 56, we put a 56 as the superscript that's up top. And then it's optional because the fact that it's iron tells us its atomic number, but the atomic number of iron is 26. So some people like to put the 26 on the bottom. When we write in this way, it's the atomic number on the bottom and the mass number on the top. Go ahead and try writing these elements using the isotope notation. All right. I have started doing those practice problems myself. And so, for instance, for potassium 39, we write K-39 or potassium-39. Or we can write the symbol for potassium, which is K, with just its mass number. Or you can put the symbol for potassium with its mass number, and you can look in the periodic table to figure out its atomic number, which is its number of protons. Potassium 40 would be all the same things, except instead of writing 49 or 39, we write 40. Copper, we could do the symbol for copper 64. You can write the name copper 64. Again, you can do just the symbol, just the mass number, or we can look it up on the periodic table and we can include the atomic number of 29 as well. And lastly, we have phosphorus 30. I'm sorry, you can't see what I'm writing. I'll show it in just a second. There we go. And so we have phosphorus 30. You can put a P with a 30, a P with a 30 on top, and then you can find it on your periodic table, and its atomic number is 15. All right. The next thing I wanted to talk about was average atomic mass. So we just talked about isotopes and the idea that you have different versions of the same element. Well, the average atomic mass is the way we calculate based on all of the different versions that are out there. So if you have a chunk of coal is made of carbon. It would have lots and lots and lots of atoms of carbon 12, carbon 13, and carbon 14. Those are the most common versions. The average atomic mass of coal is not going to be just adding up those three numbers, though. If we averaged 12 plus 13 plus 14 and divided by 3, we would get 13. But if you look at the periodic table of carbon and you look at the mass number, the average mass number is 12.01. And that's because this is calculated using a weighted average. They take the one that's most common and it's worth more in the average. The ones that are less common are worth smaller amounts based on how common they are. This is the same as what we do with grading in our class. The test category is worth a certain percentage. The homework category is a percentage. They're not all equal when we calculate your grades. As I mentioned, the mass number was 12.01. So let's take a look at hydrogen as well when we look at the atomic mass number. So again, hydrogen, if you look on the periodic table, the number on the bottom is 1.01 AMU. I already told you that hydrogen's three isotopes, its three versions, are hydrogen 1, hydrogen 2, and hydrogen 3. However, the average is really close to 1. And so that tells us that the 1 must have counted more in the calculation, so it must be the most abundant version of hydrogen. And it is, very much so. So now you can look at the periodic table, and we're going to figure out the most common isotope of the following elements. I'm going to do the first one with you. Pull up my screen again. I'll shrink it a little. Oh, not like that. Okay, I'll just move it. There we go. So it says, what is the most common isotope of the following elements? And the first one it asks for is magnesium, which is right here. So magnesium's number is 24.31. So we look at that number and we decide whether we round up or keep it the same. If there's a 5 or higher after the decimal, it rounds up. 4 or lower, it stays the same. So the most common isotope for magnesium would be magnesium 24. Now let's look at strontium. It says 87.62. Does that round up or stay the same? If you're saying round up, you are correct. The most common version of strontium is strontium 88. Now we find copper. There it is. Its mass number says 63.55. That rounds up, so the mass number is 64. And last, we have gallium. That's right, it rounds up to gallium 70. Thanks for watching today, and like I said, if you didn't get all of the red copied down, you can go back to the slideshow and make sure you get it. Bye.